Hi, it's Mr. T here. This is a video on where I'm going to demonstrate how to draw a light diagram to work out the size and the distance an image is away from a mirror. In this case, I'm looking specifically at a convex mirror. So remembering from my earlier video, or what you know about concave mirrors, there are three light rays that we draw to help find where the light rays converge or appear to have converged. Now, because this is a convex mirror, this is a diverging mirror. What that means is that all of the light rays that hit the surface of the mirror will bounce off in wide directions from each other. So we'll have a light ray will come in, bounce straight, one will come in and bounce up that way, one will come in and bounce that way. They diverge. So if they diverge on the left-hand side, we're going to expect them to converge on the right-hand side. I've drawn a focal point on the right-hand side here. What we remember about the focal point is actually there is a center of curvature, twice the distance, so that's over here, 12 of these squares away. And remember, the center of curvature is the center of a curve. If I was to draw this curve of this circle, the center of curvature will be the center of the circle. Right, let's start drawing the light rays. The first one we draw is, in this case I'm going to draw, is the one that goes towards the focus and then bounces off parallel. Now, because the light rays don't converge on the left-hand side, our eye is going to see them converging on the other side. So we're going to draw a back ray, a dotted line, that is going in the same path as the reflected light ray, and the line that we would look along and expect that's where the light had originated from. We're going to draw a second light ray here. That's going to be the one that is symmetrical. So remember, it's going to start at the top of the object, it's going to hit at the principal axis here, and then it's going to come off at the same angle. So there it goes. This is our second light ray, and let's draw a light ray or a dotted line from the other side, a virtual light ray, as to where someone looking down this reflected light ray would think it may have originated from. So if you think, if our eye could at the same time look at both of these light rays, which it might do if we're looking at a mirror, we would expect the top of the object, we would think that the top of the object had originated from here, from the other side of the mirror. Now let's draw the third light ray just to be sure. So remember, that one goes parallel, and then it reflects off as though it had came from the focus. So that's the same with the first one. Well, sorry, not the first one was going towards the focus and reflected off. This one goes parallel and bounces off as though it is coming from the focus. So we can draw our back ray again, and it goes through here, and when we look at it, this is the point where we think all of the light has originated. So this is the top of our image. There it is. Now, because our image is now, in this case, is on the opposite side of the mirror to the object, it's not real, and it's called a virtual image. So when we go to describe this image, we say that it is smaller or diminished, it is virtual because it's on the other side of the mirror, and it's upright. Now, any type of position that you have an object on the left-hand side, the image is always going to appear smaller, virtual, and upright for a convex mirror. So it's quite simple. It's a lot simpler than it is for a concave mirror, where we have 5 different ways of drawing a diagram. In a convex mirror, no matter where we put the object, it's always going to be smaller, it's always going to be virtual, and it's always going to be upright. In fact, the top of the image always appears on the top of, it always appears kind of on this line here, in between the focus and the mirror. So the image is always in between the focus and the mirror. Okay, I hope this video has been useful, and yeah, watch out for my next one.